Guys, welcome to the KC YouTube channel. Today we are going to be solving some maths questions on polynomials. So basically we are going to be solving two maths questions, that's 2020 and 2016. Okay, let's look at the questions then. Now we are going to start off with June 2016 mathematics paper 2 question 1, and the question reads: given that the roots of the quadratic equation x squared minus x plus 2 equals 0 are alpha and beta, find the quadratic equation whose roots are 1 over alpha squared and 1 over beta squared. Roman 2 says, given that the polynomial p of x equals to x minus 1 times 3 times x minus 3 times k of x plus 2x minus 8 of degree 3 is exactly divisible by x minus 1, and that p of 0 is 10, find q of x. Okay, let's dive right into the solution. So we are going to start off with Roman 1. So the basic knowledge we need to get from this equation that is given are our sum of roots and our product of roots. So our sum of roots, which is alpha plus beta, is negative b over a. So we have negative 1 over 1, which is 1. And our product of roots, which is simply alpha beta, and that is c over a. So we have 2 over 1, which is 2. Now the sum of new roots, since these are our new roots, then the sum of new roots will be 1 over 1 plus alpha squared plus 1 over 1 plus beta squared, which is equal to this from LCM, and 1 plus 1 gives 2, so we are left with alpha squared plus beta squared, which is alpha plus beta all squared minus 2 alpha beta, and multiplying the polynomials below, we have 1 plus alpha squared plus beta squared plus alpha beta all squared. Now again, alpha squared plus beta squared is alpha plus beta all squared minus 2 alpha beta. So we have our sum of new roots as this, and substitute our values for alpha plus beta and alpha beta, we now get negative half. Okay, so let's look for the product of new roots. The product of new roots will be simply 1 over 1 plus alpha squared times 1 over 1 plus beta squared, which is equal to this answer we have here from multiplication below. And since we already did this in the previous slide, we already completed this and gave us 2, then our answer is simply half. That's substituting the values of alpha plus beta and alpha beta. Okay, generally any equation should be of the form, any quadratic equation should be of the form x squared minus sum of root x plus product of root equals 0. So in this case, it is x squared minus sum of new roots x plus product of new roots equals 0. And we have x squared minus, this is our sum of new roots, x plus product of new roots equals 0, and multiplying all through by 2, we get this equation. So this is our new equation. Okay, let's look at the Roman 2 then. The Roman 2 says, given that the polynomial p of x equals that of degree 3 is exactly divisible by x minus 1, and that p of 0 equals 10, find q of x. Okay, the first thing we want to understand is that p of x is of degree 3. Now, we know that this is of degree 1, this is of degree 1, and so multiplying these two, we get a polynomial of degree 2. Now, q of x is multiplying this polynomial of degree 2. So, for the result to be of degree 3, then q of x has to also be of degree 1. So, that is logically, so we get that q of x must be of degree 1. Okay, so if we just say let q of x be equal to ax plus b, which is a polynomial of degree 1, where a and b are real numbers, then we can now write p of x as this. Now, if p of x is exactly divisible by x minus 1, then p of 1 should be equal to 0, because if we say let x minus 1 equal 0, then x equal to 1, therefore p of 1 should be equal to 0 if x minus 1 is divisible by, so if p of x is divisible by x minus 1. So substituting 1 in p of x, we have this, and equating to 0, we have this function here, and simplifying all through, we now get a plus b equals 2. Let's mark that equation 1. Now, also they said p of 0 is equal to 10. So substituting 0 again in p of x, this p of x we have here, you now get b as, 3b as 18, then b is equal to 6. And again, putting b inside here means we have a plus 6 equals 2. Therefore, a should be negative 4. And since we have a and b, we can just substitute in here and we get q of x as negative 4x plus 6. Okay, let's look at the next question. So the next question is June 2020 Mathematics Paper 2 question 1, and the question reads, given that x plus 1 is a factor of f of x, so f of x is equal to this, factorize f of x completely. Roman 2 says, let lambda be a real constant, show that the roots of the quadratic equation 3x squared plus negative 4 minus 2 lambda x plus 2 lambda equals 0 are always real. Okay, so let's start first with Roman 1. Now, since x plus 1 is a factor of x, then we can now say f of x divided by x minus 1 should give us a polynomial without a remainder. So we need to get that polynomial, and to get that polynomial we just do long division here. So after doing that long division, we now write f of x divided by x minus 1 equals that polynomial. Therefore, f of x should be that polynomial times x plus 1. So f of x equals x plus 1 times that polynomial. And this is f of x factorized, but not factorized completely. So we have to factorize this again to give us monomials. So we can then split this 5 into 2 and 3x, 2x and 3x, and factorizing that, we now get f of x as this function, which is completely factorized. Okay, so let's look at Roman 2. Let lambda be a real constant, show that the roots of the quadratic equation that are always real. Okay, for the roots of the quadratic equation, or for the roots of any quadratic equation to be always real, then b squared minus 4ac should always be greater than or equal to 0. Now, some students had difficulties understanding this question. This question did not ask us to find lambda, but prove that it is always real. So basically, we are supposed to prove that b squared minus 4ac is always greater than or equal to 0. Okay, so let's look at the proof. So what is b squared minus 4ac? It is simply b squared minus 4ac, and we have this. Now opening this bracket, we have this function here, and simplifying that function that we have earlier, we have this, dividing or factorizing 4 rather, we get this thing in here, and I can break this 4 into 1 and 3. So I do this, and the reason why I'm doing that is because I want this particular expression here to be a perfect square. So if this is a perfect square, then I can write it as this. Now we all know that if lambda is real, then lambda minus 1 is real, and the square of any real number is always positive or 0. Yeah, so lambda squared or lambda minus 1 or squared should always be greater than or equal to 0, meaning if I add both sides by 3, then lambda minus 1 all squared plus 3 should always be greater than 3. Multiplying both sides by 4, we now have this. Now since this is greater than or equal to 12, then I can just say it is greater than 0. It's logical and also mathematical. So I can write b squared minus 4ac as a function that is always greater than 0. Hence, we have proven that b squared minus 4ac is greater than 0 for any lambda being an element of real numbers. Thank you guys for watching the video. I hope you liked the video. Please don't forget to subscribe, and if you face any difficulty anywhere, you can always write a comment in the comment section below. And yeah, have a nice day.